The following video is an example of adding vectors via the component method. The first step is to translate compass bearings into right triangles. So to add in problem 1, vector A to vector B, first have to get an idea of the direction of those vectors. 46.9 degrees is about there on the compass, so it is an arrow pointed in that direction. That is vector A. Vector B is in the direction of 156.2 degrees, which is down here, southeast. It's a longer arrow because it is a longer vector. So those are my two vectors. I need to then find the x and y components, but before I do that, it would help to have angles. Now, the trick is to start with the x component. So starting from the tail of the red vector, vector A, I draw on the x component, the y component. Now, in doing so, I can mark the angle measured from horizontal, which will become useful. In vector B, same thing. Start from the tail, draw the x component first, then the y, and I have a right triangle. I can mark the angle measured from the horizontal. Now, I can easily figure out with simple geometry what those angles are. This general direction is 90 degrees on compass east. So my bearing of 46.9 degrees can be subtracted from 90 to get my new bearing, or my new angle, excuse me, 43.1 degrees. That will be the angle useful in calculating, whoops, that's right, my components. Angle B can be resolved similarly, dx, by. At 156 minus 90 will give this angle, which is this angle. So I have 156.2 minus 90. .2 degrees. Okay, so I've resolved the angles. I can easily, using right triangle trigonometry, calculate the components ax, ay, bx, by. In fact, the fact that I kept the angles measured from the horizontal means cosine in this case will always be associated with the x component, and sine the y components. Notice I have circled here negative sign in front of the y component. This direction down is considered a negative direction, so we have to add a negative sign to that component. Why is that important? Well, the next step is to sum respective components. That means we have to add ax to bx and ay to ay or by to find the new components of the new vector. And there that is. I called the new vector r. You can call it whatever you like. But to distinguish between the two components, I have rx is nothing more than ax plus bx. So the resultant number from ax calculation and bx happens to be 15.7 meters. And adding the positive ay to the negative by, I get a negative 6.9. So I have a positive x component, longer in magnitude, 15.7 is a larger number than 6.9, and a negative y component for an overall vector seems to point down and to the right. I can see this graphically quickly. If I do a tip-to-tail method, I should get an overall vector that points down to the right. So this appears to be my signs match the idea of two vectors adding. Now, final steps. I need to calculate this vector length, the magnitude of this new vector. That is easy to do with the Pythagorean theorem. Rx plus Ry square root of is the vector length. And also simple is then finding this angle. We can call it theta. Pick your favorite trig function, but you have Rx and Ry. Easily calculate theta using tangent, which results in an angle of 23.7. That is this angle. However, we need a compass bearing. So we have the 90 degrees here and a 23.7 degree angle. Add that to 90, we get an angle of 113.7, or a compass bearing of 113.7. So final answer is 17.1 meters at 113.7, which is east-southeast. So again, steps. The basics are translate your compass bearings into right triangles. Break down the vectors into their components. Sum those components to get new components of the new vector. Bring those components together in a new right triangle so we can then find the length of the new vector. And finally, use that right triangle to find the angle, translate that angle into a compass bearing. The end.